In this lecture, we shall solve an example of a beam with two internal hinges for the shear force and bending moment values along the beam's length. We have a beam that is fixed at both the ends with internal hinges at some distance inwards from each of the ends. Let's label them as A, B, C and D respectively. A uniformly distributed load of 10 kN per meter is shown acting over the middle span between the internal hinges. The projections are dropped and the lengths dimensioned as shown. Now the beam overall has 6 unknowns, 3 from each of the fixed supports, and there are 3 equations of equilibrium available, with 2 additional equations from the internal hinges. Hence, we still find that the number of equations available, that is 5, is less than the number of unknowns, that is 6, by a value of 1, indicating the degree of indeterminacy. But we know that there are no horizontal loads applied over the beam, and hence it is easy to make out that the horizontal reactions at the supports are both 0. We now have two unknowns from each of the two supports with the total number of unknowns as 4, and neglecting the equation depicting the horizontal balance of forces, we have two equilibrium equations available and two additional equations from the internal hinges with the total number of equations available also as 4. Hence the beam can now be considered as statically determinate. Let's now break the three parts of the beam at the internal hinges and draw them separately. The unknown shear forces at the internal hinges are represented by Vc and Vd at the locations C and D respectively and are shown on respective parts created. Let's mark the zero datum lines for the shear force and bending moment. Now for beam CD, from symmetry of loading, we can conclude directly without going into details that Vc and Vd are both equal to 1/2 the loading value over it, that is each of value 100 kilonewtons. These values are also reflected in the adjoining parts of the beam. Without going into detailed equations, we just estimate the maximum value of the bending moment developed at the midpoint of segment CD, that is at a distance of 15 meters from end A. Let's name the location as point E. Hence, Mmax, that is M at E, is equal to W times L squared over 8, which equals 500 kilonewton meter. Here we also show the reaction force and moment developed at each of the fixed supports, though they may not be required for writing the equations for shear force and bending moment. We shall now use the values obtained to draw the shear force diagram and bending moment diagram directly. The locus of the bending moment curve for the middle segment is also known to be of a maxima type, and we shall use this information to draw the curve accordingly. In the next lecture, we shall have a practice problem on finding shear force and bending moment for the case of a beam with an internal hinge with a point load acting directly over it.